Hello once again, it's Mr. Pete, your YouTube shop teacher, and I'm here at my closing horizontal mill. And this is the first official video I'm making of me using this machine for an actual project. There's 5 or 6 videos already on the preparation of the machine, so go back and watch those if you will. In the previous videos, I think you recall that I said that there should be a total of 4 of these kick-out stops for the power feed, but actually it was only one when I received the machine. The other ones were lost along the way. After all, it's probably a 50-year-old machine. So I did in fact make a couple more. There they are, but I need the proper T-nuts that will go into this T slot right here, and that's what it looks like. So there's really only one of those at this time, so I'm going to make 2, 3, 4 more, and I'm going to use a little bit different process here than what many of you are probably used to, and that is straddle milling. So I'm going to set up this machine to straddle mill these 2, I guess you'd call it steps, at one time. Now this is not a very critical project. In fact, you'll see that this one is extremely crudely made. The center, or the hole, is drilled off center. They didn't deburr it. There's saw marks, there's grind marks, there's even a burr right there. So it's not very important, not very critical. It's something that could be made very, very quickly on my vertical mill. However, let's just say that you needed 1,000 of them, or 100, or some large number. It would be so much faster to do it by this method. However, the setup for this is probably about a half hour, well, probably 60 minutes. I'll probably spend 60 minutes getting this ready. You won't see all of that, but I'll go through the basic steps of what I need to do to set up this horizontal mill for straddle milling. So let's get started. Another project that I need to do, and this is the first project where I'm using the Kurt Angelock vise that came from my buddy Wayne down in Fort Worth. But there are no keys on this vise, so I had to set that up. So I need to make keys, but that's not the subject of this video. So what I did is I already set up the Kurt vise here, so it's perfectly parallel. The jaws are perfectly parallel or perpendicular, maybe I should say, to the spindle. And I did that using the Noga magnetic base here, along with a dial indicator and a parallel. And I ran it back and forth. So in order to do that, what I do is I tighten or snug up one of the T-bolts here, the other one kind of loose. I run it across, determine how much I need to tap it in one direction or another, and then I tighten the other one and run it back and forth a few times to make sure that I'm truly within about 1,000. So I'm within 1,000, that's plenty close, so that vise is ready to use. In order to straddle mill, I need 2 cutters, and the diameter isn't too critical. It just really doesn't matter as long as they're not just outrageously large or outrageously small. So these 2 are what, 3-inch diameter, and they're brand new, 5/16 thick, 1-inch bore, and they're still in the protective wax. So what needs to be done is these need to be mounted on the arbor together like that, and they need to be spaced perfectly to give me this 7/16 width right here, 7/16. So that's what I'm going to use. As you recall, when Chuck brought that closing mill to me from Detroit, he brought quite an ample supply of cutters, even more so than what you see here. The larger ones were already set aside. So I dug through these and found those 2 3-inch cutters that, well, was quite fortuitous, was it not? That they are brand new and really just the size that I need. Again, what I need now is an arbor spacer to space the 2 cutters apart that is more or less 4/33, which comes to fractionally, what, 7/16. So I did dig through this, and these came from Chuck. These are all the arbor spacers plus what is already on the arbor. There's one arbor that came with this, that's 1-inch diameter. But digging through these, I came up with this 7/16 thick spacer. And these are very accurately made. They're ground, and they have a keyway in them. Also, in that selection of stuff is, and I don't know if I'll need these now, but the purpose of all of these arbor spacers here, and some are brand new, made by Destaco. I showed these in another video. Probably more than I need to show you, but here are all kinds of those, and notice that some are literally shims so that you can get the spacing that you need. So I'm very thankful to have this selection of these if I need them, but I think for this project I will be getting by just fine with the 7/16 spacer. And what I'll do now is to take the wax coating off of these and determine that they truly are new and just haven't been resharpened or need resharpening, but I think they're brand new. Wow, was that a struggle. Usually that peels off just like a tangerine skin, but that was like peeling an apple with somebody that doesn't have any fingernails. That was tough. That took a lot of time, so I didn't show any of that. I think that it peels off much faster if it's fresh. So let's get these mounted on the arbor now. So I've already got one on, and that key there is long enough to straddle both of them. Now I cannot emphasize strongly enough how necessary it is to clean these arbor spacers, that there be no chips, just nothing in between them, because if there is, as you tighten this up, it does cause a bend in the arbor. So this is the 7/16 thick spacer. Make sure that's good and clean. And then the final one, and by the way, these are brand new. They're just beautiful little cutters. These are called side cutters because they cut on the periphery and the side, but I think just straight cutters that didn't cut on the side would probably suffice for this particular job. But they do need to be the same diameter exactly, and they are because they're brand new. You know what? I didn't measure them. I am taking a bit of an assumption there. And then other spacers. This could be done while the arbor is on the machine, as required, and still plenty of room for the nut. The nut. Let's go over to the mill. The arbor support is in place. Both of these clamps are tightened securely, as is this one. I have oiled this bearing thoroughly. Now I'm going to tighten the nut. Make sure you don't try to tighten that arbor nut unless it's fully supported. You can do damage. So I'll tap that. That's all ready to go. The milling machine is set for a rather slow speed, that is 100 RPM more or less, and that's what the black book calls for in a 4-inch cutter for steel, and that's cutting at about 100 feet per minute or so. This is the center hole in the end of the arbor, and I'm just verifying the speed. You can see I'm right about 100. It actually calls for 115 RPM. But the actual dial back here on the speed control, I would consider only semi-accurate. That's why I was double checking it here, because remember, this machine is new to me as well. I interrupt this video for a point of clarification. Again, what I'm doing here is straddle milling. Sometimes an operation is performed that is called gang milling. Well, what is the difference? Gang milling is when 3 or more, it could be 5, 10, any number of different cutters are ganged together to perform an operation on a particular part, various diameters, different grooves and things like that, all done in one pass. So that would be gang milling as opposed to just straddle milling. In reviewing the video here, I think I left out something, and that is I didn't talk about tightening the arbor. So the arbor is thoroughly tightened with the drawbar, which is on the back side here, and everything is secure. Now, sometimes we might need that arbor support that goes on here that was shown on the other videos. I don't believe this is a very heavy-duty operation that requires it. When I tightened the arbor, back to that real quickly, I did have it in back gears. By the way, this is back gears. To achieve a slow speed like around 100 RPM, we need back gears. And according to the pointer here, this machine is running at about 113 RPM here. So it isn't very far off. This dial isn't very far off from the true reading, which I checked with the Stewart Warner tachometer. I interrupt this video again for another irrelevancy. You may have heard the mail truck come. It's quite noisy, and that was just 7 minutes ago, and in it was a package from Randy Richard in the shop. Thank you, Randy, very much, and it's one of his 3D printed spill-proof oil cans, and he sent me a brush along with it. And there's Randy. Be sure and watch his channel. He's always got some good videos, and he's a great guy, and he was here for my meet and greet. And I just filled this with maple syrup, butter pecan, which happens to be a very, very good cutting oil, so I'll be using that here presently. The way the cutters are installed, the spindle must run in the clockwise direction, which is actually reverse. And again, it doesn't matter how you install the cutters as long as you turn the spindle in the correct direction. So you're not running the cutters backwards. I guess I said that already. All right, I'm finally ready to cut, and you can see this setup takes a long time. The workpiece is a little bit over 1 inch long, and it is 700 thousandths wide. That's kind of an odd dimension, but the width here is 7/16, as I said, and the depth of this is 1/8 of an inch, which leaves 250 here, but in other words, the depth here is 1/8 of an inch. Okay, the material that I had on hand is just a little bit wider, because in fact this is 3/4, but that's going to fit just fine in that T-slot. So rather than mill this down to equal this, I'm going to use this, and I will center this cut within this piece, as will the hole be drilled and tapped. So I laid this out. Now, you don't have to lay it out. That could be done just with dial indicators and positioning it and finding the edge and all that. Also, the depth is 1/8 inch. I've got that marked. So let me go ahead and install this on a 1 inch parallel. And this is long enough, so it's 4 inches, so that I can get 3 pieces out of there. So I'll go ahead and put that in the vise on a 1 inch parallel and tighten it down real well. As I said, we could locate this very accurately by touching off and then moving it either with the dial or a dial indicator, so that we would get this exactly centered. It isn't that critical. I'm going by layout lines. Now, I did lay these out in the shop with a height gauge, and so it's laid out very accurately. So I've already off camera here centered it from right to left, which is really in the y-axis, and locked the table. So, and I'm going to feed in this direction toward me, toward the camera, and the feed is set at 850 thousandths per minute. Again, we're about 100 RPM here approximately for those 3 inch cutters. And I've already touched off, you can't see that, but I've touched off, because in fact, I'm not going to lie to you here, I did run a sample piece there. So that's why the setup is already done here. What I did on this one is to touch off, and then I raised the knee crank 125 thousandths. That gave me the depth. So in other words, I'm fully positioned here on the depth and crosswise, and I'm ready to cut, and I know that that feed is a good feed rate, and I'll run all the way across it in one pass. So this will only be requiring one pass. It could be done in several passes if you're unsure of yourself. I consider this machine a little bit more dangerous than a vertical mill, so make sure there aren't any rags or anything around that could get caught on the cutter, loose clothing or anything of that nature. Wear a face shield or safety glasses. Always work safely. Use a chip brush to remove chips. Use a brush or a squirt oil can to apply the oil. Don't get anything in there because it would just take your finger or your hand right off. It just could be a terribly dangerous thing. Take a trial cut if you're unsure of yourself. And now we are ready to go, but take those safety considerations into mind. Turn on the spindle, and I slowly advance the work into the cutter so I can hear it or see a few chips. Put a little oil on and engage the feed. I don't know whether you heard me, but that was conventional milling, not climb milling. And at that feed rate of 0.850, that took about 5 minutes to make that cut. There it is, ready to drill and tap the holes and cut the pieces to length. Now you can see that what I told you earlier, how long the setup took, but the cut didn't take that long. So if you were making hundreds or even hundreds of thousands of these, you would want to do it probably with this type of operation. But nowadays, of course, it'll all be done on CNC machines, but this would be the traditional way that straddle milling was done. So I need just a little deburring, not very much. Those cutters were sharp enough to where there isn't a whole lot of burr, but you can see now by turning this upside down that it fits just right in that T-slot and goes in there just fine. So that's going to work. The size and the dimensions are just right, really. You know what, I decided to measure this and verify the dimensions besides just putting it into that T-slot. But the red part is 7/16, so it should be about 437 and a half. And it's 439. So that's within a thousandth and a half. And rather than measure the depth, I'm going to measure the thickness here, which should be right around 250, quarter inch. And it's just, well, there it is, just a little bit over. Yeah, it is quarter inch. So right smack on the dimensions, much closer than is really necessary for what this is. I'm very pleased with the results of that machining job. Well, that concludes this video. I just don't believe I need to drill and tap and cut and all of those operations. You've seen that many, many times on my videos and others, but I hope you liked this inaugural run here of the closing mill and the demonstration on straddle milling. Leave a comment if you liked it. This is Tubalcain saying so long for now, and I'll see you in my next video. And here are the finished T-nuts.